In the previous video, we looked at creational design patterns. So we saw that creational patterns, they provide object creation mechanisms, right? They help us create objects in an efficient manner. In this video, we look at structural patterns. So structural patterns help us assemble objects and classes into larger structures and help us to keep these structures flexible and efficient. So we are going to look at some structural design patterns in this video. The first structural design pattern we are going to look at is the facade design pattern. So let's say you have to create several objects and perform several steps. So let's say you have to initialize many objects, and for a particular task you need to execute methods in the correct order, give the right parameters, etc. Right? So, or you need to use existing complicated library functions, right? And the clients or others who are going to reuse your code, they will face an issue, right? They will have to know details about which all are the different objects to be created, what are the necessary library functions, etc. Right? And this makes it difficult for the client to use your code. So let's take an example from the seller portal itself. Let's say after a buyer places an order, the system should do the following task. The system should create an order. The system should notify the appropriate seller, prepare the packaging, and send the item out for delivery. Right? So we see that there are several steps which need to be performed. So let's look at how we can implement this in our code. Right? So we have different classes, one for order, which places the order, then a class called seller, which has a seller notification, a package class which packages the order, and the delivery class which delivers the order, right? And in my code, I have to first create an order, right? Provide the product name in this function, then create a seller, create the seller or call the seller notification function with the appropriate seller name, then create a package object and create a delivery object. So there are several steps which I need to perform, right? Once a buyer buys a product. Now let's reflect on this question. How can I make this code better for the client? Right? The client need not or should necessarily not need to know the exact steps which are required, right? So just reflect on this and see if we can find a better solution to this problem. So this problem can be solved using the facade design pattern. So a facade design pattern, it provides a simple interface to a library or a complex set of classes. So for example, let's say there are several functions and classes which need to be called, right, for a particular operation. So in the facade design pattern, you create a class which has a method which calls all the respective or required functions and places them in a single method. So in this case, do something calls all the appropriate methods in each of the individual classes. And now clients do not have to remember each of the individual function calls, but will just have to call do something with the necessary parameters. So let's see how we can make changes into our existing code to implement the facade design pattern. So the code on the right implements the facade design pattern. So we can see that the individual classes and the methods remain the same, right? So order, seller, package, delivery, they remain the same. And what we will do is create a new class called, let's say, delivery facade, and it will have a method which will take all the function calls and object creation mechanisms and place it into the single function called deliver, right? And now the client need not call all of these individual functions, nor do they have to create each of these individual objects. All that I will do is create an object of the delivery facade type and call the deliver function with the appropriate parameters. So in this way, we see that the client need not remember the different objects to be called, nor does it need to remember the exact step of which all functions need to be called. So what are the pros and cons of using the facade design pattern? So one advantage is, as we saw, that it helps us isolate the complexity of the code or the different libraries that we have and expose clients to just a single method or function. The disadvantage of using the facade design pattern is that the facade is tightly coupled to other objects, and because of this, maintenance becomes more difficult. So for example, in this case, we see that the delivery facade is coupled to the order, the seller, the package, and the delivery classes, right? And if any change happens in any of these objects or these functions, then we need to make appropriate changes in the delivery facade class as well. Now let's look at the next design pattern, which is the adapter design pattern. So let's look at the problem. Let's take the example of the Amazon seller portal itself. And let's say some products have cost in dollars or euros, and hence conversion to rupees is needed, right? And now let's say we have a product class and we have a library or a class called as conversion converter. So conversion converter is an existing library for which we do not have control of, right? So this product class cannot directly access the conversion converter class, or it has an incompatible interface to that of the product class, right? So let's say conversion calculator is an interface which is not compatible with product. So product cannot directly access the conversion calculator due to various reasons, right? So in such cases, the adapter design pattern comes in handy, right? So what is the adapter design pattern? So let's say the client wants to call method B, right? And the client cannot directly call method B. So what we can do is create an adapter class, right? And what the adapter class does is it provides a wrapper, or it provides a link between the client and the adaptee. So what the client will do is call the adapters method, and the adapter in turn will call the adaptees method, right? And these methods might be incompatible to each other, but that issue of incompatibility is taken care of by the adapter, right? So the adapter wraps one of the objects to hide the complexity of what is happening behind the scenes, right? And the client need not be aware of, what are the complexities involved. The adapter takes care of that. Now let's look at how we can implement this in our code. So we have a class called conversion calculator, which does the conversions to dollars, from dollars to rupee, and from, let's say, euros to rupee, right? And we have another class called product, right, which has the attributes of product. And for this example, let us assume that conversion calculator and product are incompatible. They cannot talk to each other, right? So what we will do is we will create an adapter called, let's say, cost calculator adapter, which acts as a bridge or a wrapper between the product and the conversion calculator, right? So cost calculator adapter takes a product P and creates an object of the conversion calculator and passes the product cost to the appropriate function in the conversion calculator, right? And if we look at the product class, we see that the product class, it creates an adapter object and it calls the appropriate adapter function. So the product need not know any of the details regarding the conversion calculator class, right? And in this case, in the main function, we create a product and we add a product. And when we call this add product function, the add product function creates an adapter object, and the adapter object gets the cost in rupees by calling the conversion calculator. So in this case, the cost was $300, and when we run the code, we get the cost in rupees. So let's look at some of the pros and cons of using the adapter design pattern. So one advantage is that we are following the single responsibility principle, right? So in our case, we separated the code to convert from dollars to rupees or euros to rupees from the actual business logic of the product class, which is to add products, edit, delete products, right? In that way, we are following the single responsibility principle. The other advantage is that if we want to add new types of adapters, let's say for other currencies, then this can be done easily. And this follows the open close principle, where we say that a class should be open for extension. So we can extend the functionality of these classes by adding new types of adapters. The disadvantage is that the complexity of code can increase. So let's say we are adding an adapter, so we have to add a new class and add appropriate methods. And if we were able to make changes in the product class, or maybe get access to the conversion calculator, then we need not create a separate class for this purpose. So in that way, the overall code complexity can also increase.